Hi, this is Q&A. Welcome. Let's talk today about ECDIS correct using.
It is very often a situation when at the ECDIS generic courses, major part of a teaching time is spent focused on system interface overview. But before the use of individual interface software, many important words usually are missed. This video session is about correct use of ECDIS. As with any other navigational equipment, ECDIS also may fail. It can become out of order or may start to provide misleading information. Due to our regret, not all software or hardware problems may be discovered immediately by a single glance of officer of the watch, and that may cause that misleading information to be interpreted and accepted as true for decision-making on the bridge. Great care always should be paid upon accepting the position information. Here we need to say that navigators should avoid relying on a single source of position information. The information about the position should be always checked and with other sources. Navigators must be prepared to identify anomalies provided by electronic equipment data. Navigators should remember that the most important sensors on the bridge are their eyes, which are redundant by nature. And ECDIS itself doesn't eliminate the need for a proper lookout, which helps to collect in one picture all accumulated information on the bridge. When an ECDIS is switched on, it goes through a series of checks, and any detected anomalies will result in an error message, generally as an indication on the screen rather than as a navigational alert. Any such messages should be noted and addressed appropriately. Guidance should be available within the user manual. During use, an ECDIS will attempt to self-monitor problems which is detected and will result in an indication or a navigation alarm depending on its severity. However, the equipment is unlikely to be able to detect all faults that could give rise to the display or incorrect navigational information, emphasizing the need for continued vigilance on behalf of the officer on the watch. If there is a major failure of one ECDIS, the best solution in that case is to use a backup station with appropriate records in ship's logbook, and assistance to solve the problem should be initiated. The presence of a backup station is a must-have solution for paperless vessels, and it is regulated by IMO. It is recognized that many ECDIS software glitches may be eliminated using a simple restart of the ECDIS station. For instance, blank or corrupted displays, freezing or slowing of the cursor movement, inability to remove system error messages rather than navigational alerts, of course, and so on. First, try to use a simple restart of the ECDIS station before requesting assistance from the equipment support company. During this shutdown and restart sequence, the ship should be navigated on the backup system, and the officer on the watch should not be directly involved with the restart procedures. It is possible the standard menu command to shut down the ECDIS should be utilized, as this will reduce the possibility of restart problems. If the first restart doesn't help, try it at least a couple of times at least. Some problems with equipment may appear due to improper use or because of human factors, when the sequence of procedures is ignored. For instance, the chat update procedure or specific ECDIS is not followed. Or one typical example more, when both ECDIS stations, primary and backup, give wrong information about vessel's position. At least before reporting this failure, we have to try to select the secondary source of position. As example, a gyro fault will limit the functionality of the ECDIS to north up, and the on-ship's heading will not be displayed unless backed by a transmitting magnetic compass. Also, radar overlays will be in error and so should not be used. In that case, heading should be taken from the magnetic compass. A fault in the speed log will result in a permanent error message on the ECDIS, but it will not affect affect its basic functionality as a chart. A fault in the echo sound may also create an error message on EGDIS, but will have little or small effect on its normal functions. So the navigator must be able to analyze system faults, distinguishing fatal errors from non-critical fault. EGDIS is a computer-based navigation system that uses electronic charts and integrates various navigational sensors to provide continuous position and navigational safety information. Failure of EGDIS can have serious consequences for the safety of navigation and the environment. Some possible causes of EGDIS failures are like power failure, sensor input failure, hardware failure, software failure, cyber attack, satellite signal disruption. A high-quality position fixing system is the most important sensor for using an electronic chart. The IMA performance standards have the next requirements for position fixing devices. To allow real-time positioning and fast decision-making, the ship's position should be derived from a continuous positioning system, for example once every second as it is stated. Whenever possible, a second independent position fixing system should be provided, and EGDIS should be capable of identifying discrepancies between the two systems. EGDIS should provide an alarm when input from the position fixing system is lost. EGDIS should also repeat, but only as an indication, any alarm or indication passed to it from the position fixing system. EGDIS is a system that uses electronic charts and various sensors to provide continuous position and navigational information. Position fixing with EGDIS is a process of determining the vessel's location on the chart using different methods and sources. The quality requirements of position fixing within EGDIS are: the position fixing system, normally GPS, should be checked frequently by using other means, such as parallel indexing, radar, visual bearings, or celestial observations. The position fixing interval should be such that the vessel does not run into danger between fixes. The speed and proximity of hazards should be considered when deciding the interval. The position fixing methods should be appropriate for the scale and accuracy of the chart. The position should be marked clearly on the EGDIS display and indicate the source and quality of the fix. The position fixing system should be reliable and secure from the external interference or cyber attack. The backup EGDIS unit or paper chart should be ready to use in case of failure. Position fixing within EGDIS is an essential part of safe navigation and should be done per international regulations and recommendations. The accuracy of electronic position fixing device in EGDIS depends on the operational requirements of the vessel and the accuracy of all other components involved. Under operational requirements, I mean the navigational area, seagoing or maneuvering mode, in the port, and the weather conditions. As for the accuracy or other components, we understand that the accuracy of EGDIS itself, which depends on the accuracy of hydrographic data in use. The accuracy of radar is comparable to 20-30 meters, let us say. So, we can mention that in some instances, the accuracy of electronic position fixing devices was found much higher compared to the chart data in the particular of the old survey. Based on the thoughts above, we may conclude that for coastal navigation, positional accuracy is effective when better than 5 meters. But for open sea navigation, a lower accuracy may be adequate. There are already propositions for the nearest future navigation task where accuracy for electronic position fixing device is established as 1 to 3 meters. EGDIS can provide many benefits for safe and efficient navigation, such as route planning, monitoring, and anti-collision. However, there are also some risks associated with over-reliance on EGDIS when using it. Some of these risks are like human error. Navigators may not be adequately trained or familiar with the EGDIS system and its functions, leading to improper use of misinterpretation of the information displayed. For example, they may not check the passage plan, the accuracy of the indices, the safety settings, or the alarms of the ECDIS. Also, system failure may appear. ECDIS may malfunction or become unavailable due to power loss, software bugs, hardware damage, or cyber attacks. This may compromise the navigational safety and performance of the vessel, especially if there is no backup system or paper charts available. Also, loss of situational awareness may happen. Navigators may become overconfident or complacent when using ECDIS and neglect other sources of navigational information, such as visual, radar, echo sounder, and AIS. This may reduce their ability to detect and avoid hazards such as shallow waters, obstacles, or other vessels. In the event of ECDIS failure, as advised, the ship's officer should take the following minimum list of actions. Here we have: inform the master and other relevant personnel, switch to backup ECDIS unit or use the paper charts, check the availability and accuracy of other navigational aids, plot the vessel's position manually and frequently, report the failure to the manufacturer and the flag state, restore the ECDIS as soon as possible. ECDIS failure should also be included in the ship's drills and exercises to ensure the crew's preparedness and competence. ECDIS is a valuable tool for navigation, but it should not be the only source of information for the bridge team. To avoid over-reliance on ECDIS, we need to check the passage plan carefully before departure, using the ECDIS chat route function and other sources of information, such as charts, sailing directions, and notices to mariners. Also, we have to monitor the ship's position frequently, using visual, radar, echo sounder, and AIS information, and compare them with the ECDIS display. We shouldn't ignore any alerts or warnings from the ECDIS or other equipment. We must ensure that the ECDIS settings are appropriate for the voyage, such as the safety count or safety depth and alarm parameters. Adjust them as needed according to the changing environment and traffic situation. We have a task to maintain good situational awareness and bridge team management, and encourage the lookout to report any observations or concerns to the officers of the watch. Use the ECDIS as a decision support tool, not a decision maker. We must keep the ECDIS software and charts updated and follow the manufacturer's instructions and guidelines for the operation and maintenance of the system. We have to report any malfunctions or errors to the master and the technical support. Actually, you are responsible for training and familiarization yourself with the ECDIS functions and features, both generic and type-specific, and refresh your knowledge regularly. Seek help from the master or other experienced officers if you have any doubts or questions about the ECDIS. This is much better compared with doing without understanding the process. Remember, there are no stupid questions, but only answers are.